Welcome back, you guys, for another deep dive. And today we are going to try to unpack a really interesting idea from the world of philosophy and logic. It's called logical constructions.
Oh, very cool.
And you actually send in some
Yeah.
excerpts from the Stanford Encyclopedia of Philosophy on this. And
Right.
to be honest, it's some pretty dense stuff.
It's dense.
But don't worry, that's what we're here for.
Yeah.
We will break it down and we will explain what's important.
Yeah, it's a really fascinating concept, I think.
Yeah.
The term itself was actually coined by Bertrand Russell,
Oh, okay.
and it's all about how we can sort of figure out
Right.
how seemingly complex things can actually be built up from simpler, more fundamental elements.
Okay.
Almost like a philosophical version of those ship-in-a-bottle models.
Oh, interesting.
You see the finished product,
Right.
but the real mystery is how all those pieces fit together inside.
Right. And we're not just talking about physical objects here.
No, no, no.
This applies to IDs too, right?
Absolutely.
Like how we understand numbers and categories.
Exactly.
Even the nature of reality itself.
Exactly. That's the beauty of it.
Okay.
Russell believed that we could understand these complex concepts by breaking them down into their logical components.
Yeah.
He was especially focused on this idea of grounding mathematics in pure logic.
Interesting.
And that's an ambitious project known as logicism.
So instead of just accepting mathematical ideas as
Right.
givens, he wanted to show how
Exactly.
they were built from the ground up using logic as the toolbox.
Precisely. It was all about rigor and clarity.
Okay.
He even had this great analogy
Okay.
where he compared accepting axioms without proof to theft over honest toil.
Wow.
He much preferred the honest toil of carefully constructing concept step by step.
I love that.
Yeah.
So how did this honest toil actually play out?
Yeah.
What was one of his first major constructions?
Well, one of his most famous examples is his construction of natural numbers.
Okay.
So instead of just accepting 2 as you give in,
Right.
he defined it as the class of all pairs.
Okay.
So anytime you have a pair of things, 2
Right.
shoes, 2 cats, 2 ideas,
Right.
they all belong to this class that represents the number 2.
Wow, that's a pretty radical shift in thinking.
It is.
So he's basically saying that numbers aren't these mystical entities,
Right.
but rather logical categories built from simpler concepts like pairing.
Exactly.
It's like reverse engineering the number 2.
You got it.
Yeah.
And this has some really interesting implications, too.
Okay.
Because it suggests that mathematics, at its core, is deeply connected to logic.
That makes sense.
Yeah.
But what about all this talk of incomplete symbols and fictions?
Right.
These are the parts that really trip me up.
Okay, sure.
When I was reading the Stanford Encyclopedia article.
Yeah.
Can you explain those a bit?
Yeah, sure. Those are key to understanding Russell's approach.
Okay.
Let's start with incomplete symbols.
Okay.
Think about phrases like the average person or the ideal candidate.
Okay.
We use these all the time.
We do.
But do they refer to actual specific people?
Not really.
Not really. They're useful concepts,
Yeah.
but not concrete individuals.
Yeah.
That's the essence of incomplete symbols.
Okay.
They gain meaning within a particular context, even if they don't have
Right.
the direct one-to-one correspondence with things in the world.
Okay, that helps.
Yeah,
So it's like saying the average family has 2.2 children.
exactly.
There's no actual family out there
Right.
with exactly 2.2 children.
Right.
But we understand what the statement means because we're thinking about averages and statistics.
Exactly. And that leads us to fictions.
Okay.
In this context, Russell is using fiction, kind of like how we talk about a corporation being a legal person.
Right.
We know a corporation isn't a person in the usual sense,
Right.
but it's a useful legal fiction
Right.
that allows us to apply certain rules and concepts.
Okay.
Similarly, Russell argues that some concepts, like certain types of classes,
Yeah.
might be best understood as logical fictions,
Right.
not fundamental entities,
Right.
but useful tools derived from something more basic.
So we're talking about building up complex ideas.
Yeah, exactly.
Even if those ideas don't necessarily represent real things in
Right.
the traditional sense.
Precisely. And that's the ingenious part of logical constructions.
Okay.
We can use them to build up a more nuanced and sophisticated understanding
Okay.
of the world around us.
Okay, I'm starting to see how this all fits together.
Good.
We're taking complex ideas
Right.
and breaking them down into their logical building blocks.
Yeah.
And sometimes those building blocks might not be concrete things,
Right.
but rather more abstract logical concepts.
You're getting it.
Okay.
And what's amazing is that this approach isn't just limited to abstract concepts like numbers.
Really?
Russell actually tried to apply this idea of logical construction to the physical world as well.
Wait, really?
Yes.
So he was trying to explain the existence of matter itself through logical constructions.
He was.
Now that sounds really interesting.
It is.
Can you explain how that works?
Of course. And that's where we'll pick up in
Okay.
the next part of our deep dive.
Great. I can't wait. Okay, so last time we were talking about how Bertrand Russell was using these logical constructions to explain things like numbers and classes,
Right.
and you were just about to explain how he applied this approach to understanding the physical world,
Yes.
which sounds pretty mind-blowing.
It is mind-blowing.
Yeah.
He basically tried to explain matter itself as a kind of logical construction
Wow.
built up from our sensory experiences.
Let's hold on. Let me get this straight.
Okay.
He was saying that physical stuff, like tables and chairs,
Yeah.
aren't actually fundamental things in themselves,
Right.
but rather they're built up from our perceptions.
Exactly. It's a radical idea, right?
It is.
He was drawing on the work of his collaborator Alfred North Whitehead,
Okay.
and they called the raw data of our senses sensibilia.
Sensibilia.
Yeah, imagine all the colors, the shapes, the sounds, the textures you're experiencing right now.
Okay.
Those are your sensibilia.
Okay.
And Russell and Whitehead believed that they were the building blocks of our experience of the physical world.
So instead of thinking of a chair as this solid, independent object,
Right?
they're saying it's more like a mental model that we construct based on our senses.
Precisely. It's like you think about how a table looks different depending on the lighting,
Right.
the angle you're viewing it from, or even your mood.
Sure.
Our perception of the table is always changing.
Right.
But we still have this sense of it being a stable, solid object.
Yeah.
Russell and Whitehead would argue that this sense of stability is a construction,
Okay.
a way of organizing and making sense of our ever-changing sensory input.
Okay. I can see how that fits with the whole idea of building up complex concepts
Right.
from simpler elements.
Yeah.
But it's definitely a very different way of thinking about the world than we're used to.
Absolutely. It challenges our common sense assumptions about what's real and how we know it.
Right.
And this idea was further influenced by the rise of relativity theory at the time,
Oh, okay.
which showed that even things like space and time are relative to the observer.
So just like our experience of here is different from someone else's experience of here.
Exactly.
And those experiences are always changing as we move.
Right.
Russell and Whitehead were suggesting that even our perception of solid objects is relative and constructed.
Exactly. And Whitehead especially really dove deep into trying to figure out
Okay.
how we could construct these fundamental concepts like points in space and instants in time
Wow.
from our experience of events. It gets very technical.
Yeah.
But the main idea is that even our sense of a continuous flowing world
Right.
is built up from these discrete bits of sensory information.
I see. So it's kind of like those time-lapse videos where you see a flower blooming in fast motion.
That's a perfect analogy.
Yeah.
We perceive the blooming as this smooth, continuous process.
Right.
But it's actually built up from a series of still photographs taken at different moments.
Exactly.
And just like how different cameras can capture different perspectives of that flower blooming.
Right.
Russell and Whitehead believe that different observers, each with their own unique set of sensibilia,
Okay.
could still construct a coherent shared picture of the world.
That's pretty wild. So they're basically saying that the world, as we experience it,
Yeah.
is a kind of collaborative project built up from the individual sense experiences
You got it.
of all the observers in it.
It's a radical and thought-provoking idea
It is.
that challenges our assumptions about what it means for something to be real.
Right.
And raises all sorts of questions about the nature of perception and objectivity.
This is all really fascinating, but I'm also wondering about how this idea of constructing the world from sense data
Yeah,
squares with the way we actually measure and quantify things in science.
right.
The Stanford Encyclopedia article mentioned something called measurement theory. As an alternative approach, could you explain that a bit more?
Sure, that's a great question. So around the same time that Russell and Whitehead were developing their ideas about logical constructions,
Okay.
a physicist and philosopher of science named Norman Campbell was proposing this different approach called measurement theory.
Okay.
And instead of trying to figure out the ultimate nature of what's being measured,
Right.
measurement theory focuses on the procedures we use to assign numbers to quantities.
So instead of asking what is length,
Right.
we ask how do we measure length?
Exactly. It's a more pragmatic approach.
Okay.
Think about how we measure the length of something with a meter stick.
Right.
We don't need to get into a philosophical debate about the true nature of space or distance.
Right.
We simply align the meter stick with the object and read off the number.
Okay.
Same with weight. We use a balance scale and compare the object to standard weights.
Right.
It's all about the operations and procedures.
So it's less about the what and more about the how.
Precisely. And this shift in focus had a big impact on the philosophy of science,
Okay.
raising questions about the relationship between our measurements, our observations, and the underlying reality we're trying to understand.
That's a pretty big shift. So we've gone from constructing numbers to constructing matter.
Oh, right.
and now to questioning the very way we measure the world.
We have.
It seems like these ideas, even though they came from different perspectives,
Yeah.
are all interconnected somehow.
They are. And what's fascinating is that even though measurement theory offered an alternative to Russell's focus on logical constructions,
Okay.
the legacy of his work lived on and influenced many other philosophers.
Oh,
In
interesting.
fact, one of the most important figures in 20th century philosophy, Willard Van Orman Quine,
Okay.
was deeply influenced by Russell's approach.
So even though Russell's ideas about constructing the world from sense data were pretty radical, they still had a big impact on later thinkers like Quine.
Right. And, Quine was really interested in clarifying our concepts and making our language more precise.
Right.
And he saw a lot of value in Russell's approach of breaking down these complex ideas into simpler ones.
Okay.
He called this process explication.
So it's kind of like taking a messy, complicated concept and cleaning it up,
Yeah,
making it more precise and easier to work with.
that's a great way to put it. And what's interesting is that Quine also recognized that there might not always be just one right way
Oh,
to explicate a concept.
interesting.
He acknowledged that there could be multiple, equally valid constructions, each with its own strengths and weaknesses.
So it's like having different ways to build a chair. As
Exactly.
long as it's sturdy and comfortable, the specific design choices might not matter as much.
Exactly. A great example is the definition of ordered pairs.
Okay.
There are several ways to define them using set theory,
Right.
and each has its own quirks, but they all achieve the same goal, representing a pair of elements in a specific order.
So Quine took Russell's idea of logical constructions and added this layer of flexibility,
He did
recognizing that there might not be one perfect way to build up a concept.
precisely. He emphasized the importance of choosing constructions that are useful and serve our purposes,
Right.
even if there are alternative ways to achieve the same outcome.
Okay.
And this pragmatic approach has been hugely influential in contemporary philosophy.
It sounds like this idea of logical constructions has really had a lasting impact going way beyond Russell's original work.
It has. It's a testament to the power of his ideas
Yeah.
and the way they've resonated with other thinkers.
Right.
And while the specific details of his constructions might have been debated and refined over the years,
Sure.
that underlying principle
Right.
that we can break down complex concepts into simpler ones to understand them better
Okay.
has proven to be incredibly valuable in various fields, not just philosophy.
That makes sense. After all, we're always trying to make sense of the world around us.
Right.
And sometimes the best way to do that is to break things down into smaller, more manageable pieces.
Exactly. And as you continue to explore philosophy and logic and other areas of knowledge,
Yeah.
this idea of logical constructions can be a really helpful tool.
Okay.
It can encourage you to think critically about the concepts we use every day
Right.
and to appreciate the intricate ways in which our understanding of the world is built up.
So to wrap things up, we've taken this deep dive into logical constructions,
We have.
starting with Russell's efforts to ground mathematics and logic, and ending with Quine's focus on explication.
It's been a journey.
It's been quite a journey.
Yes.
And we've seen how this seemingly abstract idea has had a profound impact on our understanding of not just mathematics,
Right.
but also language, the physical world, and even the nature of knowledge itself.
Absolutely.
It really highlights how powerful a simple idea can be when it comes to shaping our understanding of the world.
It does, and it reminds us that even the most complex ideas
Yeah,
can often be understood by breaking them down into their constituent parts.
that's a great takeaway. We hope this deep dive has given you a solid foundation for exploring these ideas further.
We do, and if you'd like to delve deeper into this topic,
Yes.
we highly recommend checking out Russell's Metaphysical Logic by Bernard Linsky.
Oh, very cool.
It's a great resource for understanding the complexities and nuances of Russell's thought and the lasting legacy of logical constructions.
Wonderful. Well, until next time,
Yes.
keep those brain gears turning.
Keep the